All right, okay, let's have a look at example 1. In example 1, we're asked to calculate the value of x. And in example 1, figure A, B, C, D, E is a pentagon. Now, if we're to find the value of x, the first thing we have to do is to determine the sum of the inclusive angles. Now, the sum of the inclusive angles of all polygons is given by the formula S is equal to n minus 2 multiplied by 180 degrees. So it's n minus 2 180 degrees. Now ABCDE is a pentagon. So because it's a pentagon, n, which is the number of sides, is equal to 5. And so S would be equal to 5 minus 2 multiplied by 180 degrees. So this would be 3 times 180 degrees, which is equal to 540 degrees. All right, so S is equal to n minus 2 times 180 degrees. Calculate the sum of the internal angle of all polygons, where n in the formula stands for the number of sides. Now, since the sum of the 5 interior angles is 540, it means that 2x plus 2x plus 121 degrees plus 104 degrees plus 91 degrees is equal to 540 degrees. All right, so the sum of the interior angles must add up to 540. 2x plus 2x is 4x plus, so let's add 121 plus 104 plus 91, and we get 316. And this is equal to 540. So this is a simple equation. Therefore, 4x would be equal to 540 minus 316. 4x would be equal to 224 degrees. All right, next I'm going to divide both sides by 4. And so we're going to get x, because 4 cancel 4, would be equal to 5, sorry, x would be equal to 56 degrees. So x would be equal to 56 degrees. In example 1, we're asked to calculate the value of x, and we found that x is equal to 56 degrees. Let's have a look at example 2. All right, in example 2, we're asked to do the same thing to determine the value of x. All right, now the figure is A, B, C, D, E, F, which is a hexagon. Now, if it's a hexagon, it means that it has 6 sides. And so S, the sum of the interior angles, would be equal to n minus 2 times 180 degrees. And here n is equal to 6. N, which is the number of sides, is equal to 6. So this is 6 minus 2 times 180 degrees. This is 4 times 180 degrees. And this becomes 720 degrees. So the sum of the 6 interior angles at A, B, C, D, E, and F is 720 degrees. So therefore, I can use that information and form an equation that 3x plus 2x plus 100 degrees plus 3x again plus 127 plus 93, and this is all equal to the sum of all of these six angles is 720 degrees. All right, so let's add 3x plus 2x plus is 5x, 5x plus 3x is 8x, so this is 8x plus 100 plus 127 plus 93, and we have 320 is equal to 720. Therefore, 8x is equal to 720 minus 320. So 8x is equal to 400. Divide both sides by 8, and we get x is equal to 50 degrees. All right, let's have a look at example 3. So in example 3, we're asked, how many sides does a regular polygon have if one of its interior angles is 150 degrees? All right, so first of all, the interior angle and the exterior angles add up to 180 degrees because they're angles on a straight line. So first of all, the examiner says that this polygon is a regular polygon. It means that all the interior angles, each interior angle, all interior angles have the same magnitude. All exterior angles have the same magnitude. Additionally, the sum of the exterior angles of all polygons is 360 degrees. All right, so first of all, let's get the size of one exterior angle. This would be equal to 180 degrees minus 150. So one exterior angle is equal to 300, is equal to 30 degrees. All right, so one exterior angle is equal to 180 minus 150 because the exterior angle and interior angle must add up to 180 degrees. They are angles on a straight line. Check your notes and you will see. All right, now because this is a regular polygon, um, all the exterior angles are the same. So let us say that there are n exterior angles, and each of them measure what? 30 degrees. It means that 30 times n would be equal to 360 degrees. All right. If there were 5 of them, it would be 5 times one interior angle. If it was, all right, so n, which is the number of sides, if I divide both sides by 30, I have 30 n is equal to 360 degrees, and this is the sum of the interior angles. There are n interior angles. N is the number of sides. That is what I don't know. If I multiply the size of one interior angles by the number of interior angles, I'm going to get 360 degrees. If I divide both sides by 30, I'm going to get n, which is the number of sides, is equal to 12 sides. All right, so this is one way of looking at it. Another way you could look at it is to just use a formula approach. So what I tried a while ago was to communicate an understanding. A formula approach could look something like this. The number of sides n is equal to 360 degrees divided by one exterior angle. So n would be equal to 360 divide by 30, which is 12 sides. All right, so you could have approached it like this. All right, so we're to also find how many sides does a regular polygon have if its interior angle is 150 degrees. Now, if its interior angle is 150 degrees, it means that one exterior angle would be equal to 180 minus 156 degrees, which is equal to 24 degrees. And the reason this works is because the interior angle and the exterior angles, they're angles on a straight line. So n, the number of sides, is equal to 360 divided by 1 exterior angle is equal to 360 divided by 24, and this is equal to 15 sides. And so if one interior angle of a regular polygon is 156 degrees, that polygon has 15 sides. All right, let's have a look at number 4. In number 4, we're asked what? Sorry, is it possible for each exterior angle of a regular polygon to be 48 degrees? All right, this is a very interesting question. And to solve it, what I'm going to do is say, let n be the number of sides. So I'm going to let n be the number of sides. Now, the number of sides multiplied by the size of one exterior angle must be equal to 360 degrees. Now, n, this is important, n must be a natural number. N must be a natural number. Why? Because n is the number of sides. The number of sides of a polygon cannot be a decimal. You can't have 5.5 sides. You understand? So n must be a whole number. If n comes out to be a whole number, then we can say yes, the polygon can have 48 degrees as the size of one exterior angle. If n, however, does not come out to be a whole number, we are going to have to say that no, 48 degrees cannot be the size of one exterior angle of a regular polygon. So n, 48n. Why? Because if you add n, the shortcut for adding n 48 times is just to multiply n by 48. So this is equal to 360 degrees. If I divide both sides by 48, I'm going to get n. Therefore, n would be equal to, so this is 360 divided by 48, and we get 7.5. So therefore, my answer is going to be no. The question is asked, is it possible for 48 to be, for each exterior angle of a regular polygon to be 48? The answer is no. And the simple reason, because when the exterior angle is 48, n is going to come out to be 7.5, which is impossible. All right.